I'm John Zimmerman with the City of Washington Wastewater Treatment Plant. We are here at our new wastewater treatment plant here in Washington, Missouri. And this plant is the first plant of its kind in Missouri, a vertical loop reactor and cannibal sludge reduction system. We have 4 vertical loop reactors. Number 1 is on the far end, and we're standing by number 4. The mixed liquor from number 4 goes to the splitter box and then goes into the 2 final clarifiers. From the final clarifiers, the sludge settles out and goes to the effluent where it is disinfected with ultraviolet disinfection. This is our Scada system where we monitor the plant's operations. With the Scada system, we can turn equipment on and off. We can put it in auto or manual mode. We can turn, open and close valves, a number of different operations. We can, with our operations, the main part of the plant is the vertical loop reactors is our main process. There we monitor the ORP and the dissolved oxygen. The ORP is monitored in vertical loop reactor number 1 and number 2. The dissolved oxygen is monitored in vertical loop reactor number 3 and 4. If there's an alarm or a problem anywhere in the plant, that part of the screen will flash, and we'll get the alarm bar down here will also flash. You can go to the alarm screen and look at what the problem is and go out into the treatment plant and repair or make adjustments to what's happening. There are about 18 different screens here that we can go to and look at more specific information. The drum screen, part of the cannibal sludge reduction. We have a side stream going upstairs that we can adjust the flow to that drum screen. We can look at other screens for the VLR air and look at how the VLRs are performing, what blower's running. Okay, we're in the wastewater treatment plant laboratory, and Gary's doing solids testing here. The Gooch crucibles come out of the oven, the drying oven. They go to the desiccator for 15 minutes to cool. From the desiccator, after the Gooch crucibles are cool and dry, it gets weighed on the balance. Then goes over to the filter apparatus, and you filter through a measured amount of influent or effluent. And then it goes back to the drying oven. It dries from the drying for 1 hour, the drying oven to the desiccator to cool for 15 minutes, then back to the balance to be weighed for the final weight. Then the calculations are made so that we can have our milligrams per liter to put in our lab book and on our data sheets. Here, standing in front of the influent structure, where all the raw sewage enters our wastewater treatment plant, we have about 2.5 million gallons of water enter our treatment plant on a daily basis. We're in the headworks of our wastewater treatment plant. Our influent or raw sewage flow comes up. We measure the flow with mag meters on all 4 pumps. The influent channel, we measure the depth of the channel, which then can open a second gate if we have influent infiltration. Okay, this is one of our 2 bar screens. They're Parkson. As the channel level comes up here, as the bar screen blinds, the float will tip, the bar screen will clean off, drop the screenings onto an auger, send the screenings downstairs to a compactor, where the compactor then bags up the screenings. The screenings then are hauled to the landfill. So most of the raw material, the coarse material in the raw sewage is screened out right here. A lot of the objectionable debris. From the bar screen, the raw sewage continues on to the head cells for the grit collection. Okay, this is the grit snail. The grit snail is collecting the grit that's from the head cells after the sewage passes through the bar screen. The colloidal material settles out, and you can see the grit in the stair steps here being dewatered to drop down into the hopper and go to the landfill from there. Okay, this is our grit removal control panel. Inside there's a programmable logic controller, a PLC, that gives us the information to the Scada as to how all the things are functioning on the grit system. And all of the operators here are cross-trained. We all communicate on a daily basis as to any problems that occur anywhere in the treatment plant. Okay, this is where our main utility comes in. Behind me is where Ameren Union Electric panel is, our switchboard. Our main control disconnects, and then our generator controls, which if the main utility goes down, we can then, our generator will operate our entire treatment plant. When the utility comes back on, there's not even a blink in the lights. The switch over is very, very smooth. Of course, in a normal situation where a storm goes through, the utility is out. It takes a couple minutes for the generator to come on, where all the equipment will then, all the process equipment will then come online. All the process equipment is controlled by or monitored by programmable logic controllers. This panel here is for our influent pumping, for our influent pump station that pumps everything up to our headworks. There's a programmable logic controller in there, and then on this is the programmable logic controllers for the main part, for the vertical loop reactors and for all the headworks in our treatment plant. Goes out and talks to the equipment, talks to the pumps and motors, gives us that feedback back to the Scada system, and we can monitor the system from here. Okay, this is our effluent structure. We measure the effluent flow in a partial flume over here, and then the ultraviolet disinfection. It goes through the effluent, goes through 2 channels. We have 2 sets of banks in each channel with 3 modules in each bank. The first 2 modules for ultraviolet disinfection are on during normal flow periods. When the flow increases tremendously, the second set of banks comes on and handles the additional flow. Due to flooding on the Missouri River periodically, we are on the southernmost point of the Missouri River here, and this is bottom land, and we have to have high water pumping. When the water reaches flood stage, a little beyond flood stage, the high water pumps will come on to lift the water to a higher elevation, which will then push the water out into the Missouri River. We take in the raw sewage, we treat it, we discharge a safe water meeting far exceeding NPDES permit requirements for the state of Missouri. During the high public contact periods out on the river, we disinfect our water. That is from April 1st through October 31st with our UV disinfection system. I want to thank you for touring our plant here in Washington, Missouri. Anytime you're in Washington, give me a call and set up an appointment. We'll be glad to talk to you about any of our processes and any of our equipment.